Okay, let's dive into this. Welcome to the Explainer. Today, we're tackling one of the absolute most common, yet ridiculously frustrating challenges in database management, and that is slow queries. Look, if you're a developer or a support engineer, you know that optimizing a database can honestly feel like trying to untangle a giant knot in the dark, all while the server alarms are blaring in your ear. But today, we're going to turn the lights on. We're looking at how MySQL Workbench's Visual Explain feature completely transforms the way we troubleshoot performance bottlenecks.
We have literally all been there. It's a busy Tuesday, production is under heavy load, and a critical report query just timed out again. You know the exact one I'm talking about. It's hitting an orders table with over 100,000 rows in your payment schema, quietly eroding system performance and causing some serious user friction. You need to fix it, right? But where do you even start? Because staring at a spinning loading wheel sure doesn't give you any clues.
So here's our game plan for today. We'll quickly run through Section 1, the slow query pane, Section 2, explain versus explain analyze, Section 3, decoding visual explain colors, Section 4, fixing full table scans, and finally, Section 5, the 5-minute support fix.
Section 1, the slow query pane, from guessing to knowing. Traditionally, the workflow for identifying and fixing these slow queries has been painfully manual. You check the slow query log, you find the culprit, and you run an explain statement. But let's be real for a second. Reading raw, tabular explain output isn't exactly a walk in the park. Unless you have deep, specialized database expertise, it just looks like a confusing wall of text that requires a PhD in MySQL to decipher. You're staring at columns like type, possible keys, and extra, trying to mentally map how the engine is executing your query. It takes a ton of time, and time is literally the one thing you don't have during a production issue.
Section 2, explain versus explain analyze, the diagnostic lenses.
So, the crucial point here is understanding the difference between these two diagnostic commands. When you run a standard explain, you're just getting the optimizer's estimated execution plan. It's basically a what-if scenario. MySQL is telling you what it intends to do without actually running the query. But introduced back in MySQL 8.018, we got explain analyze, and this is a game changer. This command actually executes the query. It returns not just the estimates, but the actual execution time, the real number of rows processed, and the loop counts. It gives you the absolute ground truth of what happened under the hood.
Section 3, decoding visual explain, colors, a triage system.
MySQL Workbench takes all that hierarchical JSON data from an execution plan and translates it into a visual flowchart. Think of it like a heat map for query performance. You read this diagram from bottom to top and left to right, and the absolute best diagnostic aid here is the color coding system. Blue nodes represent very low-cost operations, like a primary key lookup. Green means low to moderate cost, which is typically an efficient index lookup. Orange signals higher cost operations, like scanning a range within an index tree. And red? Well, red is the siren. Red highlights the most expensive operations, which are almost exclusively full table scans.
And this brilliantly illustrates exactly what we are looking for. When you hit that Explain Current Statement button in Workbench, the dark-themed interface immediately draws your eye right to the red and orange nodes. You don't have to parse through a massive table of text anymore. That red box screaming full table scan on the orders table, that's your primary target for investigation. It acts as an instant, built-in triage system.
Section 4, fixing full table scans, the enemy of speed.
A full table scan means the database is literally reading every single row to satisfy your query. But why does the optimizer actually choose to do this, sometimes even totally ignoring an existing index? Well, there are a few specific conditions. First, if a table is incredibly small, say fewer than 10 rows, a full scan is actually faster than navigating an index tree. Second is a lack of sargability. It's actually crazy how often even senior developers accidentally cause table scans by wrapping indexed columns in functions like using month sale date. The engine can no longer use the index and just has to scan the whole table. Third is low selectivity. If your query matches 30% or more of the table, MySQL figures it's just faster to read the whole thing sequentially. And finally, data type mismatches, like comparing a numeric column to a string, cause implicit conversions that completely disable indexes.
If you were stuck looking at the raw tabular output, a full table scan shows up as type all, paired with a missing or null key. That type all is the exact bottleneck we need to clear out, so we can transition our operation to a healthy, efficient blue or green node.
Section 5, the 5-minute support fix, a practical workflow.
Okay, imagine you're a support engineer. A high-stakes ticket comes in about a slow report query. By following the 2026 Best Practice Protocol, you can pinpoint and fix this methodically. Step 1. Identify the exact query using the slow query log and a tool like PT-Query Digest. Step 2. Paste it into MySQL Workbench and generate the visual explain diagram. Step 3. Verify those estimates by running explain analyze. Step 4. Add a targeted index. And finally, Step 5. Verify the fix and monitor the database to ensure the disk I/O pressure has actually dropped. Methodical troubleshooting always beats guessing.
Now, what's really interesting about this visual approach is how it empowers Step 2. When you run the query in Workbench and see that red node, you can actually hover your mouse right over it. A tooltip pops up, giving you incredible detail. You instantly see the exact number of rows examined that are being processed completely unnecessarily.
Let's say you hover over that red node for our problematic report query, and you see this number, 1.5 million rows examined. The database is checking 1.5 million records one by one every single time this report is run. Yeah, no wonder the system is grinding to a halt.
So, we move to Step 4, remediation. We realize an index is missing. We added targeted composite index, making sure we followed the ESR rule. That stands for equality, sort, range, to design the absolute most efficient index possible. Once that index is applied, we go right back to MySQL Workbench and rerun our visual explain to prove our fix actually worked.
And boom, look at the difference. We run explain analyze again, and our rows examined plummets from 1.5 million down to just 10. The node in Workbench immediately transitions from a glaring red to a calm, efficient green. The actual execution time drops from minutes to mere milliseconds. We didn't guess, we let the data and the visual heat map guide us right to the bottleneck, and we proved the fix was successful.
As our sources remind us, optimizing a database isn't some one-time magic trick. It's an ongoing, methodical process. It takes careful design and strategic indexing. But with tools like Explain Analyze and the visual Explain flowchart in MySQL Workbench, that entire process becomes incredibly accessible. You're no longer flying blind.
So I'll leave you with this final thought. The tools are sitting right there in your Workbench. The very next time a production query times out and the pressure is on, are you going to waste time guessing and reading confusing walls of text, or will you click one button and let the visual heat map show you exactly where to look? I highly encourage you to open up MySQL Workbench today and run Visual Explain on a query from your own slow query log. Thank you so much for joining me for this explainer, and happy optimizing.